Hello everyone, we'll get started. It's 7 o'clock. I like to start on time. There's probably still a few people who are yet to appear, but that's okay. They'll just have to catch up. My name's Aaron. For those who haven't met me before, I co-organise this meetup group with another gentleman called Nigel, who's not here tonight. My background is I run a web hosting company, just a small one here in Brisbane, and Nigel runs his own Ruby on Rails company, which is a programming language. And tonight I'm pleased to have a guest speaker here. This is Chris. He's got his own company, SSH Foundry, and he's got to talk about a very important topic, one that I've actually had a bit of personal experience with, having been hacked many times, and my clients. Running web hosting company, you have servers. Clients have all sorts of things on those servers that I don't even know about, and it happens. It does really happen. So pleased to announce Chris, and I'll just let Chris go. He's probably got a small intro on your own. Yep. So you just clip that onto. Yeah, throw that in your pocket.
All right.
All right.
All right, well, good evening, everyone. My name's Chris Horsley, and yeah, I'm running a small company called SSH Foundry, which I'll talk a little bit about soon. So the theme for tonight is how poor web security lets criminals make your business help theirs. And so what I'm going to talk about is, firstly, what are the main risks for those of us running online businesses or businesses with an online component. Then what we're going to do is delve a little bit into the criminal underground that carries out these types of attacks. And we're going to talk a little bit about what their motivations are and how they're looking to make money off us as business owners. Then a little bit about what the actual impact on your business is, that even if this is a widespread problem, how does it affect your business particularly? And then finally, I'll talk about some simple countermeasures. So I hope we can all go out of here tonight with just a few simple rules to really start the thinking about maybe an awareness of security in our business. So firstly, introduction to myself. So I started off life in IT some years ago as a web dev guy back in the 90s, back in the Perl and the CGI days and all of that. And I was like a sysadmin as well. So at the time, I guess the web was really just starting to pick up and become mainstream. And at the time, I was writing a lot of these web applications. And I've been doing this for a while, and it suddenly hit me that in much the same way that when we write any sort of application, it can take, it's controlling our machine essentially, is that we write a Windows executable and it's running commands. So if we could hijack that program, we can make the computer do things that was not originally intended. And the realization was, well, when we write a web application, it's like we're writing that Windows application and opening it to the world to come and play with it and break it and do whatever we want with it. And that's really what started me getting interested in security. So after that, I actually used to work for RACQ back in the day. I moved across to AusCert at the University of Queensland, who at the time were the Australian National Computer Emergency Response Team. And they handle things like if there is an attack in Australia, you could go and talk to AusCert, like let's say you're being DDoSed or your site's been hacked, you could go and talk to AusCert and find out how to tackle that. Then 5 years ago I moved over to Japan, and I was working for a team called JP-Cert, who are the national equivalent over there. And I just moved back last year to start SSH Foundry, which is mainly about helping security teams to improve their operations, and also consulting for businesses to help them with their level of security as well. So firstly, I was going to talk a little bit about the types of attacks we see. And we'll see that the way the media presents security is often very different to the actual attacks we see. We were just talking before that on the radio this evening, if you heard it, there was an interesting sensationalist article about smartphones and hacking smartphones with no real detail. But there's a lot of these scare stories, and they're the ones that tend to get all the media. Like this. So this is an article we've seen lots and lots of in the last 3 years. So this was Sony getting attacked. The reason they got attacked was, I can't even remember now. But these particular types of attacks are usually for ideological reasons or sometimes political reasons. Maybe Sony uses DRM, or they do something that's a bit against the ethos of certain groups. And lulzsec is one, and Anonymous, of course, is the other one that's become very famous in the last few years. And these guys broke into the database and they managed to lift, yeah, 1 million passwords and credit card details. And this was a really big article, and Sony ended up having to spend a lot of money. You might have remembered the PlayStation Network, that got hacked as well. Credit card information got extracted out of that. And those are articles that get a lot of press, obviously, like this. But now what we don't hear about so much are all the little sites that get hacked every day. And they don't have millions of credit card numbers, and they're not anywhere near as famous as Sony. So we're not going to hear about them in the media, but they are happening. So every day, there's all these sites all over the world, and I don't know, I'll make up numbers, tens of thousands, hundreds of thousands of sites that get compromised. And we have to ask, if they're not going after the millions of passwords like they would with Sony, what are they after with these sorts of attacks? So before we can understand that, we have to look a little bit about maybe how they do this. Now, I remember, once again, way back in the day, remember in the mid-90s, we really viewed web pages. They used to call them brochureware. So we had the idea that a web page, it was just pictures and text. So the company homepage or the government homepage, if you go back to the Wayback Machine or something, there were a grey background with text and some really ugly spinning GIF icons and things like that. And at the time you're thinking, well, how can you do anything with security with a document, right? Because all it does, it just displays text and pictures. What could you do with that? And I didn't realize at the time how wrong I was. Documents are actually the easiest thing to break into. The main threats in the last, say, 3 or 4 years have been web pages, PDF files, Word documents, Excel spreadsheets. And the reason for that is documents are actually very, very complicated. When you think about all the functionality you can do in a web page, like forms and tables and JavaScript and ActiveX, they're all conduits that open vectors of attack. So when, for example, we render a web page, the browser has to make guesses at how to reconstruct that web page again. And what we often see is a lot of software vulnerabilities in HTML rendering or PDF rendering or Word doc rendering. So the basic point I'm trying to get at is web pages can do a lot more than display web pages. We can do a lot of bad stuff with a web page if we know the correct techniques and our users aren't patched correctly against it. So here's an example. This is a website I found in the wild a few months ago, and it's for an Atlanta home loans company. And I have no idea about the reputation of this company. Looks a bit like a bit of a bit of a budget website, perhaps. But yeah, so just looking at it, it looks like text and pictures, exactly what I said. What we have to do to actually assess the level of security or the danger or the risk of this website is look at the code behind it. And it looks a bit like this. I don't know how we can see that up the back, but you can probably see this big block here. This big block, and it says things like, it's like -r plus 11, comma, -r plus 101, -r plus 104, and it goes on for hundreds and hundreds of characters. So the first thing we have to work out is, I mean, if we saw this, we'd instantly think, well, that's a bit strange. I wonder what they're trying to do there. What they are trying to do, this is often called obfuscated code or packed code. And the idea of this is we're going to write some bad code on this website, and we're going to take advantage of some software bugs in a web browser or Internet Explorer, say, or Firefox or something like that. Now, if I write the attack straight in HTML, let's say, in easily readable language, I could easily write a tool which looks for those sort of strings, right? And I could say, well, if I see those strings, don't load the web page. Let's block that attack. So what you do instead is you use this, you make your own little code, and you build it like this, which means that every time you run the attack, it looks a little bit different. So you can make like a special seed value, so that even if the logic of this code is the same, the profile looks totally different. So it's hard for me to write a tool that can just scan the strings of a web page and decide if it's good or bad. So what we can do, though, is we can run this code in a safe environment. So a safe environment is something that's, it's offline, it's on a computer where if the computer gets infected, it's not going to spread to the rest of the network, I'm not going to lose data, I'm not going to get my bank account details stolen. When you run it through a tool like that, you end up with this, which is actually quite neat code. So we don't have to understand what all the code does, but I'll draw your attention to a couple of bits. And where's my mouse gone? It is, no mouse. This line here, which has iframe, and then we've got an SRC, and it points to this other site, michellecollier.com, and then some other weird characters after that. And down here we see it again. We see another reference to an iframe and an SRC. So what this is doing, this is a very popular means of attacking a website, is using an iframe and pointing it to another site I control. And the reason we do that, well, the reason I would do that as an attacker is because I control this website. I've broken into another website and I've implanted bad code in this. So if I can make a whole bunch of websites point to my bad website, I can keep tailoring the bad code on that central website, and I can keep changing my attack, monitoring the attack. It's good for the manageability of my attack. You have to think of these attacks as like an IT project almost. Think about how they might think about how they would manage their project of trying to infect people's computers. So what happens is we go to the second site, we go to michellecollier.com, and we see some code that looks like this. And once again, this looks pretty hard to read. We see these long strings of A's here, which looks really bizarre. But we've got a few clues as well. So we have this thing here, embed type equal, it's a Java applet. And up there, we have something which is a CLS ID. And that's probably the best clue we have of all. That is the identifier for a control that loads in the browser. So by looking up this control using the power of mighty Google, we can find out what control does it relate to. And we find out it's this one, Java Deployment Toolkit Insufficient Argument Validation. And it goes on and it says, including the execution of an arbitrary jar file. So what this means is, to break down these 4 slides, if you load this web page, they can run any code they want on your computer. And the meaning of that is, I break into your website and all of your customers start getting infected with any virus, any piece of malware that I want. So basically I can now remote control your customers and I can make them do things. And I'll talk about what those things are very shortly. So the basic way it breaks down is, so this is our pristine business website. It's sitting there currently unmolested. An attacker manages to find the website and somehow, and I'll talk about the attacks very shortly, an attacker manages to get into our website and they manage to somehow add extra information. They add an attack which is going to start doing bad things. Quite often what they do as well is they'll point that site over to what we call a payload site. And the payload site in the previous case was that michellecollier.com. It's that central site which I control as well, and I can send out bad types of code and I can centrally monitor it, centrally control it, try to keep it up and running. Then what happens is we've got our website which is now serving bad code. And we get a bunch of regular visitors who come along to the website. I remember back in the day, these sort of attacks have really been around at a guess maybe 5, 6 years. Before that, we could say to people, oh, don't go to website. What they used to do is they'd send you an email. And they'd say, oh, there's this interesting thing on a website. Go and look at this website and it'll be some sensational news or something. And on the website, you get infected. So at the time, we could say, oh, don't go to websites that you haven't heard of before where it's got a suspicious looking domain. But they don't do that anymore. Now what they do is they'll go and find a trusted brand, they'll go and infect that, and then they get to infect all the regular customers of that site. And that's happened to, almost any corporation you'd want to name has had an incident where they've infected their own customers. It's happened in Australia with government websites. The Sydney Opera House website got infected a few years back, started infecting people. But the net result of this is the regular visitors, your customers, get infected and they become what we call a bot. A bot is like a zombie. So once they've been attacked, they're now running this code, and let's say I'm the controller of the botnet, sometimes called the bot master or the bot herder. I can run commands on these machines and make them do whatever I want. And this may run into, might be 1,000 machines, might be 10,000, might be 100,000. In some cases, there have been reports of botnets of 1 million machines. So I have 1 million machine zombie army. And that can be used for all sorts of things. At the very low end, there's teenagers who rent a little 1,000 machine botnet to go and hit some guy that sort of annoyed them on Xbox Live. And it goes from that level right to a higher level that we'll talk about very shortly, where you can make some serious money. So the next thing we have in this structure is called a command and control. And what happens is once I've infected these machines, I need some sort of a conduit to tell the bots my bidding, essentially. So they're going to connect into this command and control channel. And traditionally, this was done via IRC. So you can imagine that these bots are all connecting into this, this chat room, and then I have special privilege in the chat room to send commands. And the bots will see the command I typed, and they'll all go away and run that command. What we're seeing now more frequently is using a web page for command and control. So the bots every 15 minutes will go and hit a web page and look for new commands. More sophisticated ones are actually using peer-to-peer. And the advantage there is that with a web page or an IRC channel, somebody like me who works for a security team can maybe take down that control channel, right? So the bot master loses control of the bots. With peer-to-peer, if I knock out one bot, it's a very resilient architecture, and the rest can just keep on going. And I need to knock out the whole thing. Or maybe I have to find a weak point, which might be quite difficult to take the whole thing out. And then on this end, we have the controller. In this example, they would be sitting in the channel and issuing the commands and making them do whatever it is they want. So the next thing I wanted to talk about, that's how they do it, and that's the impact of what happens to your customers when they go to the site. So what we have to work out now is, why are they doing it? I mean, they're not just doing it for fun, right? I mean, back in the 90s, when you got infected with a virus, there'd be a really cool graphic on your screen. And remember, there was the stoned virus. It would say, your PC has been stoned. It would do something fun. There'd be a little ASCII art of an ambulance going across the screen. They don't do any of that stuff anymore. It's all done very stealthily, and it's done with a very financial motivation. And this has been the trend for about the last, let's say, 10 years. It's been a very financial incentive to infecting machines. So what I'd like to talk about is what they tend to call it the underground economy. And the underground economy is one where it's a perfect market economy because, well, it's pretty illegal and nobody's doing any regulation over it, and it's designed to let criminals talk to criminals. And what you find, just like in regular IT, everyone has a specialization. There'll be a security guy, there'll be a database guy, a PHP guy, a server administrator, and they all pool their talents and their resources to get the project together. The idea of these types of sites is to do the same for criminals. There'll be some guys who are experts at laundering money, some who are expert at setting up the websites, some who are expert at infecting web servers, some who are expert at writing malware. These guys can pool their resources and manage to extract more money on the whole and take a bit of a cut each. The sort of things we see in these types of forums. So these forums, they're like a trust community. So the first time you enter into one of these underground economy forums, you're an unknown quantity. And you've got to build your level of trust in that economy so people trust you. So you can do like trades with them. So in this example, this is a post from one of the members, and it says, I have these drops available. So in this kind of lingo, drops often refers to financial data. So credit card data, bank account data. So I have these drops available in large quantities, city worldwide. In Australia, I have Commonwealth, National Bank, ANZ, Westpac. In the UK, Lloyds and Halifax. I can also make drops within Asia within a week. Reach me via ICQ, often used for comms between these guys, to discuss turnaround time, percentage, operation-specific details, timing, payment details, etc. It's a very professional setup, and they all have these commercial deals as to how the operation will technically proceed, what percentage of the profit will each member of the group take. So this is to give an idea of how organized the people who do this sort of thing are. So how do we actually go about making the money? How do we turn a machine infected with a piece of malware into money? So the first example, which is pretty self-explanatory, I think, is spam. So spam sounds simple enough on the surface. So all we do is we blast out emails, right? And then some company will pay us for everything some sucker buys off these emails. But then there's some tricky bits to it. If I send 1 billion emails from a single mail server, there's a lot of organizations devoted to making a blacklist of these types of mail servers, and then some of the these other mail administrators, they'll block any mail coming from these mail servers that are known to be sending spam. So how would a botnet help me there? So if I've got a network of, let's say, even 10,000 or 100,000 machines that will do anything I want, I could set myself up to have 100,000 mail relays. So instead of sending 1 million emails from one machine, I could send 10 emails from 100,000 machines, say. And so each of those machines, 10 emails is not very many, and it's going to fly under the radar. That's not an abnormal amount of traffic to be coming out of any host on the internet. So this is probably the most basic way to make money. You can send spam with all these machines that you've recruited. The next one's kind of interesting, DDoS extortion. Is everyone familiar with what a DDoS is?
Better explain the acronym.
Sure. So DDoS is a distributed denial of service attack. So denial of service is the sort of the security lingo way of saying you can't connect to that machine. So you've taken the machine down, nobody can connect. Distributed denial of service is when...
It's like IP flooding, is it?
Yeah, well that's one of the techniques.
Flood your IP address.
All you do, because if you imagine any internet connection as the famous series of tubes, and if I manage to fill up the tube, nothing else can get through. So what I do is I take my 10,000 or my 100,000 machines and I just hammer the target with data and nothing else can get through. Or I take down, or maybe the CPU on that server can't handle the load and it just overheats basically and it starts dropping connections. So DDoS means that I can take your machine off the internet. Now, how can I make some money out of that? So there was a great scam. The first wave of these scams, there's a really great series. Actually, I think it's I can't remember. Christian Scientist, I think, is the name of the periodical. But the first groups to get hit by this were the online casinos that run out of the Caribbean. So if you think about these sort of companies, right? They run there to avoid certain regulations and taxes and things like that, and often out of some sort of law enforcement jurisdiction. So now they're online casinos, right? So 100% of their money comes from having their websites up and running, having the gambling working and online. So what happened in some of the first attacks were one of the operators of one of these online casinos noticed that their website went down for 5 minutes, and they panicked. And then in 5 minutes it came back up, and they went, oh, that was weird. And then about 5 minutes after that, they got an email. And the email said, oh, did you notice your web server just went down for 5 minutes? That was me. If you want to stop that happening again, you can pay me $40,000 US. And if you don't pay me, every day that price goes up by $10,000. So it becomes the classic mafia extortion scam. Pay me money or you can't do business. And for these businesses who, I don't know what they earn, but I'm guessing it might be in the millions of dollars per day, what's $50,000, right? So a lot of them just paid. And the police, particularly at that time, the police really didn't have a handle on online crime. Online crime is very difficult to legislate because, if you've got let's say a purse snatcher, everything happens in one jurisdiction. It might all happen in Brisbane, say. That's all Queensland police. But what happens when the target is in Jamaica and all the attackers are in Australia and Russia and Brazil, and the attacker themselves is somewhere in Eastern Europe? Which of those pieces of law enforcement are going to be responsible? So these attacks are often also it's very difficult to organise the law enforcement together to shut them down. So that's how you make money from a DDoS extortion. Threaten to shut them down and ask for money to stop that happening. Paid per infection. So some companies, I haven't seen this so much lately, but particularly in the early 2000s. Remember how everyone used to get hit by those annoying adware programs, and you'd be using your computer and it would bring up some flashing banner in your your tray bar there, and you have to click to get rid of it. So quite often, and they're selling a fake antivirus product or any number of dodgy things. But the companies who are selling the products, they'll pay you to get that onto people's PCs. So now if I have a botnet of 100,000 machines and somebody's willing to pay me $5 to put one of these adware programs on a machine, well, that's some pretty easy maths and some pretty easy money too. So that's a pretty straightforward way to make some revenue out of your botnet. Botnet for hire. So I mentioned before that these criminals, they all have their own specialization. So the guy who runs the server, the guy who builds the malware, the guy who manages the botnet. So managing a botnet, that's a real speciality, that's a skill. So maybe I know how to build and control a botnet, but I don't understand all the financial stuff, like I don't understand how to launder money. Or maybe I don't like the risk of it, because as soon as you're interacting with a victim, the risk of your arrest, say, it goes up quite a bit. So instead what we have is a botnet for hire. I control 100,000 machines. If you pay me 2 cents per bot per hour, I'll slice off a piece of my botnet and I'll hand it over to you, and I'll give you even a lovely web interface so you can tell those bots what to do. And then once your allotted time is over, those bots will come back under my control and you can pay me to keep the operation going. So I can basically rent out my infrastructure. It's like crime in the cloud, that I can send it out and I'll slice a piece of my infrastructure just for you. Bulletproof infrastructure. So bulletproof is a term used often in underground economy as well. And what this really amounts to is business redundancy. So if I'm building any internet service, if I want it to stay up and I've got enough budget, I'm going to build all sorts of redundancy. I'm going to put it in multiple data centers. I'm going to have multiple servers. I'm going to have multiple internet connections coming out of it. And the reason I do that is redundancy. I want that to keep running in the event of any sort of failure. Now, criminals who run these sort of websites, so phishing is the big one. If you're familiar with phishing, is the fake bank site, right? So you lure people into your fake bank site, and you get their username and their password. So I'm essentially operating an online criminal business, and I need to keep that business up somehow. Now the problem is, if I go and put that phishing site on the internet somewhere, somebody like me who works for a security team, we're very closely tracking all of these attacks. And so we'll go and tell the ISP where that site is. We'll say, hey, there's a phishing site over here. You might want to have a look at it and shut it down. And it's at the point where a lot of these phishing sites, they only last maybe for a couple of hours, maybe a couple of days. In the beginning, I mean, when this really started kicking off in 2003, 2004, they could be up for a week because nobody understood the problem at that point. But now a lot of people understand it very well. So I want longer than 2 or 3 hours for my phishing site, right? Because that's how I'm making my money. So instead what I do is I put it on this bulletproof infrastructure. And that can either mean an ISP that are friendly to sort of criminal enterprises, or maybe what I could do is put it on 10,000 machines on a botnet. So I go and try to shut down this phishing site, but I find there's no one point that I can take it down. It's actually scattered across lots of machines, and I find if I take down one, well, there's 9,000 other machines that will keep hosting that phishing site until I can find some other way to dismantle the whole infrastructure. So that's another way I can make money by keeping my other criminal enterprises up for longer. And finally, click fraud. So there's ways you can make money, as I'm sure a lot of you know, from, I'll host this ad, and then for every click, you'll pay me a referral fee. Well, what if I had 10,000 machines which could simulate clicks on the ad? That's some pretty easy money as well, and I can make it seem like 20 or 30,000 people click that ad, and I will make whatever it is, I don't know what the going rate is, 5 cents, 10 cents, $1 for every click of the ad. So the next question is, so that's how they make money. The next question is, how do they do it? How do they get into the web server at the beginning and manage to sort of kick this all off into play? So there's a lot of ways they do it. I'm just going to cover a few here. So the first is probably one of the most prevalent now and for the last few years, and it's SQL injection. If you're not familiar with SQL injection, it generally stems from a fundamental programming error. And that is, most web apps, of course, interact with a database, and it will look something like this, except let's cover up this bit here, right? So I'm expecting people to look up my online catalog, and we're going to look it up in the database using a number. Well, what if the user doesn't give me a number? What if they give me a semicolon and another SQL command? The database doesn't know the difference if I haven't written it properly, and it will blindly go and run any command that any user gives it. There's ways to defend against this that I'll talk about shortly, but it seems so basic when you think about it, but that Sony incident I was telling you about before, that was SQL injection. Most of the big attacks, most of the easy attacks now, they're SQL injection, and there are tools that will let you automate this whole process. I launch my application, I point it at a website, and the tool just goes running all over the website, doing a few tricks to work, just like prodding at it. Just working out where the weak spots are. When it finds something that looks a little bit flexible, it'll investigate that a little bit more, and I will get back a report of likely points that I can intrude on the website. So SQL injection, it's very serious, and everyone seems, at least in the security community, has been harping on about it for a long time, but the problem is still, it's still rife. So the next one we have, it's in a similar vein, I guess. It's called cross-site scripting, which is abbreviated to XSS normally to avoid calling it CSS. And what that is generally about is it's when me as the attacker can control the output on your website. So how would I do that? One way I can do it is, let's say I'm filling out a form and it says, oh, what's your name? So normally we're expecting somebody to type in something sensible like Tom. But what if they type in script alert hello script? If my web application blindly accepts that as being their name, and then I present that, let's say there's a page which is, oh, here's the last 10 people to join this website. If my web application just blindly sends that out and puts it on the web page doesn't know which, or the HTML code and the browser, they don't know what's supposed to be the name and what's supposed to be code, so this code executes. And in this case, this is a test really, but you of course can put in some code which is far more malicious and will run other executable files, run malicious Java files, all sorts of stuff. And that comes from a lack of input sanitization. I'll go over that a bit later too. Next one is weak SSH and FTP credentials. So normally most websites, they need some way we're going to drop the files onto the site, right? And usually two popular ways to do that are SSH, to have a secure shell, and FTP. If you were to go home and look at your SSH log tonight, if you've never done it, it's very interesting to do. Have a look and you will see every day there are hundreds and thousands of attempts to log into your SSH server. And they try random usernames, random passwords. They basically have a script which has a dictionary, and they will just run through all the names in the dictionary and then a whole bunch of passwords. And if you've got a weak password, they'll probably find it. So if you've got an account called root and your password is carrot, they will probably, or Alpine, they'll find it. Because they're running this script that just runs thousands of times a minute. And they'll probably manage to break into it, and once they're into the server, they'll be able to edit your HTML files. They'll be able to change your web application to once again serve things that you didn't plan to serve to your customers. And they'll do it in a stealthy way. You might not even know it's happening unless you're using some sort of special tool, or until one of your customers says, hey, my machine got infected with malware. And eventually you manage to put it together after a week or so of getting these reports. The last one that's very common is known software vulnerabilities in blogs and shopping carts. So when we talk about a software vulnerability, it's generally a bug in the code that lets me do something that the original programmer didn't expect. And that generally means something like, you made a mistake. We were talking before about WordPress plugins. There's lots of them, and there's lots of, let's say, they haven't necessarily been trusted and proven yet. So if I load any sort of WordPress plugin on my site, I'm not trying to pick on WordPress, it's just, I suppose, very commonly used. If there's a point in that code which contains a cross-site scripting bug or an SQL injection vulnerability, then I've introduced that bug onto my website. And if you're using a common piece of software like WordPress, or a common piece of blogging software, or an e-commerce, like a shopping cart, say, the good and the bad thing about using widely used web applications are that, obviously I don't have to write it myself. That's nice. But if there is a problem with it, the criminals fall over each other to write tools to scan as much of the internet as they can to penetrate these systems that are running it. Because what normally happens is somebody will, there's lots of security researchers, right? And they're poking and prodding all sorts of software to work out where the flaws are. And once they find it, they announce it to everybody. And that's when the race starts. And then everybody uses the information that's been released to go and find out how we can exploit it. How can we break into systems using this bug? What you even find is the first guy to break into the server will then patch the server to make sure nobody else breaks into it after him. So he can keep control of it all to himself. Because some other guy could come along with the same vulnerability, right? Kick him out of the server, and the first attacker loses his infrastructure. And I know I use his, which is politically incorrect, but 99%, it's pretty overwhelming at this point. All right, so the next question is, we've talked about all these things that criminals can do to make money. And so far, we've talked about your server being compromised and your customers have been infected. And let's be very selfish for a second. And we'll say, okay, my customers got infected. Well, they didn't know it was me. And I really don't like my customers that much. And it doesn't bother me that much, really. And I want to convince you that actually you should care about it. And there's actually a number of very good reasons why you should and why it affects your business, even if you're not the one getting the piece of malware on your system. First one is blacklisting. So a lot of the big search engine companies, so the Googles and the Microsofts, they are working very hard to fix the problem of, so a couple of years ago, they used to call it sort of, you can use SEO, as, it's already a bit of a, how would you say, a bit of a mysterious art, but you can use it for very dark purposes as well. So some attackers worked out that I could use SEO techniques to boost the ranking of my attack site to the top rankings of Google. So that means if I go to Google, and what they do be very crafty about it too, if there was a big story, like let's say there was an earthquake or a hurricane, I would immediately work on being the #1 site for that term. Let's say it was, I don't know, a Japanese earthquake. And I want to be #1 site. So all the people rushing to get news about this big event, they're going to click on the #1 site on the listing, right? And because I've managed to game the system, that's me, and all the people went to my site, and I just rack up all of these infections, and I build my botnet. So companies like Google and Microsoft are working very hard on automated ways of detecting these sites. So they can say, that site has got malicious code, so what I'm going to do is put it in a database. And I'm going to list all the bad sites. And so when people try to visit them, I can stop them visiting. And if you use something like Chrome or Firefox, you'll get a message like this if you try to go to an infected site. And obviously for you as a business owner, that's just bad. Because I don't see any buttons on this message that says, I don't care, let me go to the site anyway. They all say, get me out of here or tell me about why the site was blocked. They don't let you go through.
Yes, they do. Click it twice, you go through.
They get me out of here?
No. You go, no, why is site blocked? Click.
Yeah.
Do you still want to go to the
and
site?
it'll say, definitely, are you sure?
Yeah. And you go to the site. Yeah, I've had that happen to a few sites.
Sure.
I've done a few sites deliberately.
Sure.
Where I've had clients, for black hat purposes, want me to put malware on their server.
Oh, really? Right.
And a Viagra page.
Yeah.
And then send 150,000 hits to the Viagra page. Google says, hey, this place has been infected, which is awesome. You keyword it, and then what happens is your site drops for about 3 weeks.
Yep.
And then all the backlinks that you get actually are registered through Google. Your site actually comes out stronger and actually penalise you for 2 to 3 weeks to say, hey, poor bugger, you've been hit by malware. And at the end of it, it goes, hey, guess what? You've got all these backlinks, your traffic's increased, your PR rankings has moved higher.
Really?
And congratulations, have a nice day.
All right.
There is some crafty stuff you can do with using the hack stuff to actually increase your sites. But
very interested to chat to you about that afterwards then.
Word of caution. Yeah, look, I wouldn't do it unless you know what you're doing.
There's a fair, I mean,
but of course,
just the fact that people are seeing this message as they come in, it doesn't build you a lot of confidence about the business, right?
I've got the Australia's most trusted privately owned stock market website in Australia, started in 1996, called Goldie, which I own, which gets 1.2 million page views. For some reason, we got some malware, and I had that for 3 weeks.
Yeah.
And you should have seen the emails I was sending to Firefox and
I bet,
etc. Got to expletives after the 3rd week. But the site, as I said, actually even I didn't put malware on that one, but it came back stronger and it's better and all the rest of it. But it's a pain in the ass. But my clients, my site traffic didn't drop.
Really?
That much? Probably about 18%.
Yeah.
Because everyone, it's a trusted site. What's happening? They'll just keep clicking through it. So
we're interested to look at a case study about that. That's sort of an effect that's not generally a bit of an unintended effect, maybe. So
all right. The site was hacked. It was hacked as soon as I bought it from the company that I bought it from. Yes.
All right. Well, I'm really interested to have a chat to you because I had never thought about that before. That you could actually come out of it stronger.
Oh,
but
100%.
right.
You can, 100%.
Right.
You keep the backlinks and you've had this boost of traffic, right?
Right.
So therefore, Google says, geez, I'm going to re-rank this and use this because it's had a massive boost of traffic.
Really?
You keep, like, people that smash things, you can't destroy someone else's site by giving them backlinks, right? Unless you use homepage backlinks that are known by a link farm from Google, where it will hurt a site. And that's to stop Google, that's to stop me destroying your website. I'll just send 100,000 backlinks to your website tomorrow, and I'll destroy your site. You'll go down the rankings and I'll go up.
All right. I'd be interested if that's still the case because, as we know, they're always tweaking and tuning things, and so.
Google's fundamental proposition is, hey, there's a massive amount of traffic, etc.
Yeah.
Sometimes there might be a please explain, but it's to stop people from doing it. Otherwise, we do that to our competitors, and we wouldn't be doing it to our own sites.
Right.
And we'd be continually fighting each other. And,
right.
And just be back and forth.
Right. Well, I'll still contend this is a bad thing.
Yeah.
Right.
Yeah, it is bad.
But I'd be very interested to see how that effect might work in practice. So that's very interesting too. All right, so yeah, drop in search. I guess that's what we were talking about just then.
Yeah.
Is you could see your site bump down the listing as a result, and it depends on the search engine provider, and it depends on how they feel that month. Because and I guess as anybody who does SEO knows, like the rules are not cast in stone, and they're always changing and always being tuned and tweaked by the search engine providers. And certainly that's true with their security features. So Google will do something like this. So if I type in the name of a known malware site, it'll just under the site it will say this site may harm your computer. And obviously that's also a bad look for any website. And if you were to click that link, I didn't test it, but I would assume you would then get that nice big red warning message as well, because these are generally driven by the same databases. And as you mentioned as well, what they tend to do is once you're on the blacklist, you're not going to be on there forever, but it could be a few weeks. Because they firstly wait for you to have cleaned up the site, then they have to come back and visit you again, because they're not going to visit you every minute. They might do it every day or every couple of days or something like that. Depends on the particular spider and the popularity of your website. But once again, this means you get knocked out of search rankings, that you get warning messages and all this bad stuff. Antivirus blocking. So another way that other types of companies that build these types of blacklists and databases are antivirus companies. And so if you're running Symantec or Trend Micro, whatever it is, a lot of the new packages, the antivirus suites, they'll have their own database or blacklist, as well as let's say a detection engine for attacks in websites. So you'll load the web page up, and before it's actually rendered into the browser, it'll say, hang on, that bit of code, that looks malicious, so I'm not going to let you load the web page. So that's another point where your customers may not be able to get through to your website if it gets infected. Loss of reputation, media coverage. So depending on who you are, obviously this is a bad thing when you get the messages and it doesn't build a very good reputation with your customers. And depending on how big you are, if you're a government website, a police website, journalists love that stuff because it makes a really nice headline. The police got hacked into, or security company gets hacked into. They love that one too. So depending on what sort of organization you run, you could actually cop, or Sony, you could cop a lot of publicity about this, and not the good kind, right? And the reality is, it could be a library website that gets hacked, but yet it said, oh, Australian government website hacked. And the journalists tend to, that it looks good in a newspaper or on a website. Loss of personal data. So I guess this has been the most publicized form of attack in the last few years, is that, hacker breaks into Sony and manages to steal, 1 million credit card details. And it gets to the point where if you're constantly reading the security press, you just read about all these attacks like, oh, they lost 1 million, 2 million, 10 million, 100 million usernames and passwords, and it just starts also wash over you after a while, which is not a good thing. But it's so prevalent now. It's kind of, if you start feeling angry about every single attack, you just go a bit crazy, right? So this is obviously another big problem. I don't think I have to tell you how serious it is when your customer credit card details go walkabout, or their home addresses, or their email addresses even.
Why bother? Just go to Facebook and grab all the info you need anyway.
Well, that's true. That's not that. Yeah, well.
You can get most people's birthday, address.
Yeah.
Details.
Enough to call a call centre and be them. Yeah.
I need this.
Yeah.
Can you send me out a new credit card? Can you send it blah blah blah? Within 4 days, you've got a new credit card. That person's gone and you're away.
Yeah.
I fail to see now a lot of hackers even need to worry about hacking credit cards, and they just scrape Facebook and make millions of dollars.
Oh, absolutely. I mean, and there's plenty of people doing that, and whole other scams around that too. All right, so. I guess the next question we have to ask is, how do we stop them doing all this stuff? So we worked out basically how the scam works. We worked out how they can make money. We worked out, I guess, the technical means of how this all hangs together. So what do we do to stop this happening? So what I'd like is for everybody to walk out of this room this evening just remembering two main rules. And that's don't trust user input and patch. So the first one, don't trust user input. Now this covers a lot of attacks because SQL injection and cross-site scripting, what they really boil down to is a failure to mistrust the input coming into your website. I'm just blindly assuming that what my users enter into my website is good. So when I asked them for a username, they typed a name. They didn't type script and some other bad stuff, right? So I need to not trust my user input. And I guess part of that happens is because when we think of websites, we think of this. And we think of this lovely interface, and we've got a form here, a nice clean form with a text field and 2 buttons. And I think, well, what can they do? I mean, they can only put text in this text field, and I've limited them to 50 characters, so I know they can't do more than that, and then they have to click the button. So I know exactly what they're going to do, so how could they do something bad to my site? The problem is we can't really, when we're thinking about security, we can't think on this level, because this is really just a nice layer for humans to understand. But really, it's what's underlying the website that matters when it comes down to security, and it's this. This is the same website as a HTTP query. And it's the underlying code. Now, the most important thing about this underlying code is that none of those nice rules I set up apply to me anymore. If there's any JavaScript, it doesn't run because this is text. The JavaScript doesn't understand how to handle JavaScript. If there's a form, I can ignore it because I'm not entering data into the form. I'm making my own HTTP queries to pump data directly into the application. So none of the nice things I set up on the client side, none of them matter. As the attacker, I can do whatever I want on this layer, and I don't even have to worry about using a browser. So what we need to do is we need to be less trusting. And here's a few ways we can start doing that. The first one is what we call parameterizing SQL queries. Now remember before where we had the select blah from table where the ID equals some number, and then I put the semicolon and then drop all the tables. What I can do instead is use, most modern database engines have this feature called parameterization. And when I write the query, instead of just concatenating 2 strings, so the software doesn't know where my query finishes and the input starts, this lets me do that. So instead I write a query and I say this point here, that's something from the user. And this must be a string, and then there's a comma, then there's a number, and it must be a number. And I let the database restrict the user to not writing SQL. So they can only enter data, and the database engine knows this is data. It is never a query. Anything that it gets input at this point. Usually use like a question mark in the query is a very popular way of writing this. So if you do parameterization of SQL queries, it really stops a lot of these SQL injection attacks.
So what you're saying is, in a name form, restrict, you can't use backslashes, dots, dashes. So I'm just saying parameterization of button is like,
Now the problem is, actually this is...
You're just banning the right parameters of the bad
yes.
right, inside those form fields.
Actually, that does not work very well. I'll go to my 4th point then, allow known good, not possible bad. Now the problem comes, and I think every developer tries this, and I did it back in the day, like when I was first getting started. And you go, okay, I'm going to write a query, and then somebody says, oh, did you know if I put a semicolon in your application, I can write my own SQL queries? And you go, all right, I'll block semicolon. Yes. And then they tell you, did you know if you do a double dash, that's a comment. So if I do a double dash, I can do whatever I want. So you go, okay, I'll block double dash. And then they say, and then there's a whole, most SQL engines, there's so many features in there, and they're always changing over time too. Every time I upgrade the database, maybe there's new features that I've never heard about. So the safest possible choice is to only allow things that I know are safe. Don't try to block bad things. Right. So if somebody's got a name, so if we're expecting a name, right, what do we expect a name to be? We generally expect it to be upper and lowercase characters. So what we would do is we'd write a rule that would say, if you have anything that's not an uppercase or lowercase character, I just give you an error. And I say, no, you can't do that. You have to conform to this rule. But once we start...
hyphenated name.
And this is where you end up with a lot of other problems, is that you have a Driscoll, say, with a semicolon, and you have to do a double semicolon then, and then you've got double semicolons in your query, but what if somebody accidentally typed a double semicolon when they were typing their name?
It's one person out of a billion, so I just block.
Right.
I don't care if they've got, I'll go apostrophes, I'll go dashes, but everything else, I don't care if they're Jonathan the Third. Too bad you don't get it.
Right. What you'll find as well is that using parameterization, you can use semicolons. And the database now knows that this is data, it's not a query. So you won't get errors, and it knows how to handle that data, and it knows that this is unsafe string data. So parameterization is the way to go, and definitely we need to only allow in the database known good things. Don't try to block everything bad, because you only need to miss one of those bad things, and you've opened the gate for people. So second one, or third one rather, escaping HTML. So before we talked about cross-site scripting, and that was when I allowed somebody, somehow, the ability to add extra HTML to my website. Maybe they injected it into my database, and when somebody viewed my catalog, this iframe or a pop-up happened, or whatever it was. So escaping HTML, similar idea to this. It's letting the browser know, so if there's something that looks a bit HTML-like, I can use a way of encoding or escaping any HTML to say, well, this is text. It's not HTML. Never render it as HTML. You should just render this as plain text. And without getting into details, most programming languages have some function which says, this block of text, I want you to escape it before you display it on the page, to make sure that people can't add extra HTML, which is rendered as HTML in that site. Input validation on client and server sides. So this is something I've seen so much when I've sort of been mentoring starting web developers. And they're writing their website, and they've just learned about JavaScript validation, which back in the day was like you fill out the form and you get this really annoying pop-up that said, oh, you need to put a number in your username or something like that. Everyone hates those now. But we do similar things, right? We use JavaScript to say, oh, well, that string doesn't conform to the rule, so you have to do it again. Now, remember from before, the attackers, they're not using the browser. JavaScript and all the rules, it doesn't apply to them. So the validation rules only count if they're on the server, because the server is the final place which we control, where, before it goes into the database, right? On the client, we control nothing. The client, they can run plugins, they can modify our HTML over the wire. The only place validation counts is on the server. But I'm not saying don't do it on the client, because every time we do server validation, we have to do a round trip, right? The user has to hit submit, has to go to the server, they have to check, has to come back. Why we do it on the client is usability mainly. So as they type in their username, in real time we can kind of query and say, that username's already taken, or you didn't put a number. And it just speeds things up and makes for a nicer experience for our users. So we can use client input validation, but it's only server input validation that really matters in the end. Okay, so that was about trusting data less. We cannot trust the data that comes from the clients, because we can't trust the clients. We don't have control over them. The second main point for tonight is patching. Now, this is more than just patching. I mean, I guess the most visible form of patching is Microsoft updates. So every month we get our little balloon help that comes up and it says, there's new patches. And Microsoft's gotten really good at doing that now. They don't even say, would you like to download the patches? It says, I've downloaded the patches, I've already installed them, and I'm rebooting in 10 seconds unless you stop me. So that's either annoying or good depending on your point of view. But it's more than just that. So how about your server OS? So let's say you're running on a Debian server or a Red Hat server. When was the last time you patched that? Because there are vulnerabilities in Apache, there's vulnerabilities in SSH, in FTP servers, in all of these externally facing servers or services on your server. So how often do you do that? How often do you go and you run your software update tool and make sure, because there are security vulnerabilities coming out every day. If you go and look at a website like Allcert, which is allcert.org.au, they have a listing of all of these software vulnerabilities that come out. And you might be surprised at how many there actually are. So patching your server OS, that's a really big one. Otherwise, software vulnerability and an attacker can easily scan and get into your system. Your web apps. So we were talking about WordPress before, and WordPress used to have a really bad rep because it was really widely used. And like a lot of web apps, security was something that kind of came later. Generally, when we're developing a web app, I guess, we're on a roller coaster ride of adding new features and things, and security is way down the list of priorities. And WordPress used to get broken into all the time because it was a big target. Like if you could find a WordPress vulnerability, you could compromise 1 million servers with it, potentially. But now they've got some great stuff, like when you log into the admin panel, it will say, there is a new version of WordPress available, click here to install it, and it just works like magic. So now they're actually ahead of the game, because most web apps don't do that. So WordPress are now doing a very good job at security compared to where they were before. But we have to think about, we have to keep in our minds, we can't just install the web app on our server and then forget it's there. We have to keep watching for updates from the vendor. We have to particularly watch for security updates from the vendor, not just new features, but just to fix problems that currently exist in our software. That's a gateway to getting attackers on your system. Your development OS. Now there was a really interesting piece of malware in early 2009, and it was called Gumbler. And it's kind of bad to say, but it was actually an inspired piece of malicious software. And you have to respect it. And the reason is, so most malware, you get infected and it spreads in a variety of ways. And these guys came up with a new way to spread their software. And what they did was, okay, let's say I am a website developer and I get infected with Gumbler off a website. I go to this website, it was serving something bad, I get infected, right? Then what happens is, the malware quietly installs itself on my machine. And what it does is it sets up a network sniffer. And the network sniffer just sits there quietly for maybe a few days or a week or a month, and it monitors my outgoing traffic. And when it sees connections to FTP servers, it logs the username and the password. And then it sends that username and the password to someone else, or maybe a program somewhere else. And that program somewhere else then logs into your FTP site, inserts code on your web page, and now everyone who visits your website gets infected with Gumbler. So instead of targeting the users infecting each other, they targeted developers. And the developers managed to infect their own websites, which then infected more people, and the growth of this thing was massive. So this is when I was working in Japan. And in Japan, Gumbler was so prevalent that the call centers for Panasonic, Toshiba, Sony basically melted down in a day because it was so prevalent. All these developers were getting hit, their websites were getting infected, everybody else was getting infected. It was massive. And that's why it was inspired. It was a new creative way of infecting people. And it sounds bad to give respect to it, but you kind of do have to give it. So what this means is you have to also secure your development operating system. So if I'm connecting from my laptop to my server, if somebody can control my laptop, they can also piggyback onto my connections to my server and they can take control. Or maybe I have a local copy of my HTML files on my laptop. Maybe they can insert the code straight in here. Next time I update the website, the infection goes with it. Or the code that will do the infections goes with it. So, and everything else in your infrastructure and your ecosystem. The particular point with that is banner ads. Banner ads were heavily targeted. They probably still are, but there were some early cases maybe 4 or 5 years ago. And what would happen is, a lot of sites, they serve a banner ad at the top, right? But very often that banner ad comes from another company. It's like an iframe quite often, or something along those lines. So for me as an attacker, what I do, I'll go and attack the company that serves the ads. And then every website that serves those ads, I basically get to deliver malware to their customers. So it's a very efficient way of spreading my malware once again. So you've got to think, who are the people, because essentially if you've got their ads on your site, they are controlling the code that comes out on your site, right? So you've got to think about who you're doing business with, because they become part of your online business, I suppose. And other infrastructure as well, which is things like, how do people SSH into your company? Are your routers secure? Things like that. We won't go into too much detail, but I think if you remember, maybe these three, and particularly things like ad networks and all those little things we embed on our websites, like Facebook like buttons and Google Plus Connect buttons, all of those are external content which exists on our website. Okay, so that's most of what I wanted to go over this evening, and it's a fairly, it's got a fair bit of depth. My goal tonight was really to get a basic idea of the risks, the motivation as to why you'd want to care about this, and maybe some just initial points in terms of the mindset. here are some good points or good places to read on, I think. This first one is OWASP. They are a group that is all about improving the state of the art of developing web apps securely. And they have this great initiative called the Top 10 Project. Every year, they publish a new list of the top 10 web application vulnerability, or the vulnerabilities that are used. So SQL injection is usually way up there. Crosssite scripting, that's up there. If you go and have a read of this, it will include some other attacks I haven't talked about tonight. I've talked about some of the top level ones, but this will give you a more thorough rundown to educate yourself. This one here is from Mozilla. Secure coding guidelines. This talks, in a similar vein, talks about how to write apps in a more secure fashion and what are the risks and how do we stop those happening. So the main points from tonight, so criminals, they're trying to break into any server they can get their hands on so they can deliver malware, so they can infect people, so they can build botnets, so they can make money. It doesn't just make them money, but it also hurts our business, particularly in terms of reputation and stopping our customers getting to our website so that we can make some money. And finally, don't trust user input and patch. Those 2 rules as to how we can start counteracting these types of problems. So that's it. So thank you very much. Yes, please feel free to email or whatever you like. And if there's any questions, I'm more than happy to. Yes?
A Joomla site with a shopping cart, you know how it has the update, please update what you were talking about before. Oh,
updating the software?
Yeah.
Sure.
What if it's been heavily modified? Because I pressed that once and it just wiped all the...
So you've taken the default code and then put some customizations into it, and then you want to update that? Is that what you're getting at?
Yeah, so...
Okay.
It's just basically...
I might
Sure.
help as well with this one. Did you have a web developer person help you do those customizations in the first place? You need to go back to them and say, hey, we need to revisit this. Yes, you will need to have some technical help to put those upgrades back through the ringer again and reapply those customizations to it.
That's what I thought.
Yes,
so
it's very tricky.
It
is very tricky.
Yeah, well, I mean, the original vendor, they can't sort of account for every change, I suppose. So yeah, you would have to then go and apply the patch and then roll the changes back in again, that the customizations back into the original code. So
how can you roll the changes back in?
Well, you'd have to.
That's where
there's a few software things that'll say, give me this page, give me that page, see if there's any differences. So then you'd record what you've changed from the straight modification, the go back one, like not 3.2.1, the new one, but the one you've got, get an original, compare the pages.
It's
right?
And then it's a technical thing, and whoever did the technical work in the beginning, or somebody else of their same ilk, need to do that customization work.
Yeah.
A couple of comments. First of all, on the why should I care?
Yeah.
I think you missed one pretty important one, and it's sort of the I'm pissed off factor. It happened to me. I was at someone put a crap in my WordPress site, but it was not an important site at all.
Sure.
Test site. And 6 months later, I thought, I really should get around to rebuilding this. I didn't have proper backup facilities at the time, and I spent a lot of time, maybe 3 or 4 hours. I mean, it was a fun site, so I didn't care. But just trying to rebuild it and working out what the problem was, what things I had to delete to actually get it back. So it was sort of I'm really annoyed that someone's actually done this to me.
Right.
Now I have backup, off-site backup, and I do it once a week and stuff, so that if I do get hacked again, I can just pull the whole thing down and refresh it in 10 minutes.
Yeah, but I feel like you've been violated.
Yeah, well I was, and I mean, my business was violated, and I thought, Barrett, there's nothing valuable on this site, but it really annoyed me. So that was a comment on the why.
You're right. I should include that because
it's a waste of time. And if I didn't know how to do it, I would have to pay someone to.
Yes, it can get very costly.
And it could have been $100 I've lost, $200, $300 I've lost money.
Yeah, definitely there's a lot of stress, and it's like somebody broke into your home. I got broken into a few years back and they took like $3.50 and change. Yeah. But it was the feeling of violation of somebody breaking in and touching all your stuff and all of that, yeah. Quite right.
Second comment I had was, I put my hand up, it's just using only FTP, not SFTP. Should as the second degree of security always use SFTP if the service can handle it?
Certainly it's ideal. FTP and Telnet as well. I mean, not many people use Telnet anymore, but they transmit usernames and passwords in the clear. So if anybody on your network is monitoring traffic over that network, then they can just say, oh, that's your username, that's your password. So using SFTP, or you can use SSH to transfer files as well. Either of those will then use encryption to make sure that they're not so easily readable over the wire as it goes. So I know a lot of sites, they only support FTP maybe, but I'd recommend, if possible, where possible, certainly, SFTP is the way to go.
To prevent keyloggers, I use Kaspersky's live keyboard that pops up.
Right.
Keyboard.
Yeah.
It's really awesome because if I'm doing my credit card details on my ANZ account, I pop up my virtual keyboard.
Mm-hmm.
So any keyloggers, if there's some shit on my machine, they're not logging my credit card details and username, passwords and all the rest of it because it's a virtual keyboard. They can't record the keystrokes.
All right, I'm going to be that nasty security guy now. They're keyloggers from way back. So yeah, the first generation of keyloggers, they literally, like, you pressed a key and it would log it into a file. But then they got a bit smarter, and what they started to do was, if the keylogger was installed, every time you clicked the mouse, it would take a screenshot at the same time. And it would go, oh, your mouse was over the M, and then it was over the U, and the whatever. And they could log it that way. And back in the day, I did a fair bit of work in cleaning up after keyloggers, and it's actually very painful. It ends up with reams of data it logs. So then they got even more clever than that. And what they did is they would write plugins for browsers. And what the plugin would do, let's say you're on a website and it's good and it's using a secure connection, that's all very nice. But the plugin, it can intercept data before it leaves and before it gets encrypted. So let's say you use like a virtual keyboard, and a lot of the banks do have those. If it's intercepting data coming out of the browser, it doesn't matter how you input the data because I can see it as it's leaving the browser. And there have been cases of financial organizations that have rolled out all these really fancy inside the browser in JavaScript, trying to mix up characters and doing all sorts of things. And within days, there's updated versions of malware that come out, and they know how to reverse all of that JavaScript and get the passwords back again. But it does protect you against some things. I guess my point is, like, it's not a catch-all. Like most security things, they're all about reducing risk, not about.
Really good.
Sure. I'm not trying to knock any particular product. Like, it's all about that. They have this saying of defense in depth. So no one of these things is going to potentially save you, but having quite a few of them in place, hopefully one of them will stop whatever attack that you get hit with. Yeah.
I have a third one, and the final one was that I know someone who looks very much like me, who went to the Queensland Library with a brand new Mac,
right,
which this person doesn't know how to operate terribly well, and got onto the free Wi-Fi there, surfed Google and did the surfings, and then as a matter of just social mucking around, had looked and saw that there were quite a lot of other people using the same network, and this individual who looked somewhat like me,
good friend of yours,
on someone else's Mac, a copy of their passport, their CVs, driver's licenses. In other words, that individual had not stored their stuff in a secure folder,
right,
and secondly, didn't obviously know that their stuff was open. So
yes. Well, I know. I mean,
it's sort of what I was saying is know how your operating system works.
Yes.
On your laptop.
Well, they don't make it clear. I mean, I think most operating systems have this problem. Obviously, I'm using a Mac as well. And after you shared the folder, like, you can just forget that it's being shared, right? Like, there's no visual cues that are always saying, hey, do you remember that you're still sharing this stuff? And yeah, you go into any library network and you just see this big list of shared hard drives come up on the screen. And yeah, it's pretty dangerous. Yeah.
A couple of good ideas for bullets.
Yeah.
I was going to ask if it was safer to like FTP on a Mac, like use the Mac for that.
And a Mac in particular over a Windows machine, say, or? Yeah. So the way I've heard this best explained is that Macs aren't safer than Windows, but maybe they have less risk. So what that means is Macs have software problems, software vulnerabilities. Windows have copped it for years, right? Like, they had the bad rep, like, oh, you use Windows, yeah, you'll get broken into. And it was true for a long time. But I think it was about 2003, Bill Gates sent out a memo to Microsoft and he said, from now on, security is the #1 priority. And now you go to conferences, they went from being the laughing stock to the model of how to do security right. The thing is, I mean, every month on the Mac, we get updates on Macs as well, right? So there are problems. So it more comes down to not are there vulnerabilities, but who would bother attacking it? So in most markets, it's still like, 90-something% to under 10% market share. The Macs are under 10% still, right? Or thereabouts. So if I'm a criminal, I want to make money, it's pretty obvious which one I'm going to attack, right? I'm going to attack the Windows machines because there's just a lot more of them. But I think what we'll see, and what a lot of people predict, is that as there's increasing use of Macs, if that happens, we'll get more attacks as well. And there have been attacks against it too. So there's no 100% certain answer, but at the moment, there's probably a little less risk in using a Mac, perhaps, let's say. Yeah.
But you can't run like an exe on a Mac, right? So it's got a lot of protection.
Well, that's exactly it.
Unless you're running Windows on your Mac.
Yes.
If you're running your Mac and they're trying to run an exe, it's not going to run. So a whole lot of things that would do vulnerability on a PC won't work on a Mac. So
this is right. I mean, the guys who specialize in writing malware, they generally specialize at Windows malware. Yeah. And you're right, it won't run on the Mac, but maybe that will change sometime. There's been some proof of concept stuff, not things that we've seen widely, but the early hints of it are perhaps there. Yeah. Yeah.
Take a couple of more questions.
How can you tell? Is there some software that you can run on your Mac to see if you've been compromised?
Right. So there is antivirus. It is very tricky. I don't want to paint too much of a gloomy picture. I'll start by saying, yes, antivirus. That's a good thing to run. Not running as an administrative user. That's another one that not everybody does. I believe, don't quote me, that the Mac, you become a normal user. The problem from way back with Windows is that people would just be the super powerful user on the system, which means that when I run accidentally a piece of malware, it can do anything to the system. So the idea is if I run as a regular user, which itself can't do everything, then neither can the malware. And I've got to type my password again, which you might get when we're installing software on the Mac, it asks you for another password. So that's one, run as a normal user. Second is run antivirus. There's a few tweaks you can make. There's actually some guides on the internet, like how you can make your Mac or your Windows machine a little bit hardened, block some typical types of attack. Now so I'd recommend running tools like antivirus. Now one of the problems we have is that there's this particular type of malware called a rootkit. And the idea of a rootkit is, so normally with an antivirus product, what it does is it goes through the file system and it looks for files which are matching some certain criteria, right? And if it finds one of those files, it will give you the alert and say, oh, okay, I've quarantined this or I've deleted it. What a rootkit does is that it embeds itself at a level below the operating system. So what happens is, when I'm using the antivirus program on my machine, the machine has already, before the operating system loaded, it's already been told, if you see a file called this, just ignore it. And that's the malware. So when you're running the antivirus scan, the antivirus can't see it because it's been hidden by this rootkit. And they're out there, and I don't know what the prevalence of them is at the moment. But once again, as with all of these sort of annoying answers with security, you can never give a certain answer like, oh, if you do this, then yes, you will absolutely mitigate this risk. But I know that, I think Sophos, if they had, and they may still have, a free antivirus product. So that's one place to start looking, and I'm sure there's a few others as well. Yeah?
I was about the rootkit. Hopefully that gets patched within the next 10 years, because with the new upgrades to the BIOS, the lower level kind of things, I can't remember exactly what it's called, but there'll be a new checker that no rootkit can go underneath.
There's a lot of research going on in that very area at the moment, yes.
And I think Windows 8 will shoot with that.
All the modern operating systems are now, that's one of their priorities, is getting that sorted.
So hopefully the rootkit gets eradicated within the next 10 years.
Yeah, I think so.
It'll be the under rootkit. The reverse rootkit.
Another question. Might do last question on this one, and then we'll close off and then have just more of an informal chat.
Recently I've received a couple of emails from some friends, one from a Hotmail account and the other one was from a Gmail account. And they were from my friends' email addresses,
right?
But they were obviously dodgy emails. Would that be a virus something on their computer or with email or Gmail?
Maybe, as with all of these answers. So it's actually quite tricky. What they can do, okay, let's say there's you and me and Aaron. We're sort of, we know each other. We're all in each other's address books, right? I get infected with a piece of malware. And then what it does is it opens my address book and it sends emails from you to everybody else in my address book. So you get so Aaron gets an email that looks like it comes from you, but it was really because of me. Except neither of you know that because I'm sort of hidden from the equation, if you know what I mean. So that could be a third party who you both know who got infected, or it could be the original sender. That's another possibility too. So yeah, it's hard to hammer down. I mean, what you might find is that first person might have gotten a lot of complaints, say, from other people saying, oh, I got this email from you and it looks like you've been infected. And you still see that from time to time. But it could be a third party too. Or it could be somebody who got access to a spamming database and they managed to build connections. So, yeah.
Well, that's great. Thanks very much, Chris, for coming along tonight. I'm sure we've learned something. I know I've actually picked up a couple of tips, which is good. We've got it on video, which is also quite handy. I'll encode that and put it up on YouTube, and you can watch it again at your leisure. Probably get a cup of tea next time, or a coffee or something. But I do want to stress that although Chris did cover a lot of ground tonight, whether you're a web tech type person or a business owner or someone less technical savvy, this is a very critical piece to your internet business. And it is something that it does happen on a daily basis. I know it's happened to myself and clients and a couple of other people in the audience have already stated that it does happen. And it's something that even if you don't know the technical nuts and bolts about it, at least you're more aware of it now and can talk to your tech people and say, hey, you know, how are we going? Are we secure? Are we up to date with our WordPress or Joomla installations? And just being more aware of it. So thank you very much, Chris. I really do appreciate it.